Thomas Ken, the former chief of NASA's Science Division, described the launch of the James Webb Space Telescope as the beginning of a new era in astronomy. Webb not only extends our current understanding of cosmology but also deepens our knowledge of planets and the origins of life. However, what initially promised groundbreaking insights has instead led to a crisis. Webb's discoveries have left scientists in shock. Either this situation will worsen, or we will encounter a new revelation. The discussions in physics have shifted from old theories to questioning who is right or wrong, and these debates may soon come to an end. But what does this truly mean? Have scientists truly unraveled the secrets behind Webb's extraordinary findings, or are we merely being presented with shaky explanations? Webb was supposed to offer solutions, but instead, the $11 billion project has plunged cosmology into a major crisis. Space-related branches of science, once considered foundational, are now undergoing a purge reminiscent of the medieval period, where the heliocentric view of the universe challenged long-held beliefs. Now, we must consider that the principles of modern physics might be flawed, and we have yet to grasp the true nature of our universe. How can this be possible? Modern astronomy, or the study of the physical quantities and relationships within the universe, is rooted in the fundamental principles laid out by ancient scientists, principally Sir Isaac Newton. Early observations of mechanics and elements were made, and Newton later discovered gravity, which became crucial for astronomy. Our understanding of the universe has been built upon these foundations, transferring observable quantities and forces from Earth to space, yielding consistent results. However, as the observable universe grew larger, these known quantities began to fall short in explaining what we see. The crisis began with discrepancies in measuring the age and expansion rate of the universe. Local measurements based on cosmic objects within the universe yielded different results from measurements of the early universe based on cosmic microwave background radiation. This discrepancy is now known as the Hubble tension. While the Hubble constant describes the expansion rate of the universe, Webb's discoveries in summer 2022 introduced galaxies that seem far older than previously thought, some even appearing before the Big Bang. According to current physics, galaxies should take billions of years to form, yet Webb reveals systems that were already highly evolved just a few 100 million years after the Big Bang. This directly contradicts the standard cosmological model, which states that the universe began with a Big Bang roughly 13.8 billion years ago and has been expanding ever since. If Webb's findings are accurate, then the conventional understanding of the universe's age is incorrect. We are at a crossroads. Either we are misapplying our current physics to the entire universe, or we have only scratched the surface of the true physics that exists. Ancient wisdom, such as the saying by Hermes Trismegistus, "As above, so below," suggests that the forces and principles governing the universe should also apply to Earth. Yet perhaps we've overlooked aspects of these forces on our own planet, which we now observe in the cosmos. Webb breaks all records. It is extraordinary. This telescope can detect incredibly faint light signals, thanks to its advanced technology. Webb's 18 honeycomb-shaped mirrors can capture light that has traveled through space for over 13 billion years. Its innovative techniques have made these faint signals visible for the first time. In summer 2022, we saw light from some of the most distant galaxies, ones that formed shortly after the Big Bang. These galaxies were sensational but also disappointing. Rather than young systems forming slowly, Webb reveals perfectly developed galaxies that appear billions of years old, yet according to conventional models, their age should be around 135 or 136 billion years. Modern scientists sometimes dismiss these images as unrealistic or false, but Webb shows us reality. Science must now accept that it has likely been wrong for over a century. Our standard cosmological model is far older than we once believed. What we see here is real. Webb's observations are accurate, but large parts of our science are still incapable of comprehending these new insights. Some old conservatives refuse to accept the end of the Big Bang or the idea of cosmic expansion. During the medieval period, it took years for the Church to acknowledge that the Earth was not the center of the universe, despite overwhelming evidence from astronomers across Europe. Seems little has changed. Though we consider ourselves more modern today, we find ourselves in a similar situation. Scientists who announce new discoveries may not face persecution like Galileo Galilei, but resistance to change still persists. Imagine dedicating a lifetime to studying something only to suddenly see images or evidence that tell a different story. Perhaps your mind would resist accepting it at first, and it would take time to reconcile this new truth. As with any new revelation, some scientists adapt quickly, while others take longer. Many liberal and younger researchers are thrilled by Webb's discoveries. Individuals like Rohan Natu, the founder of the Glass Z11 system, and Steffi Lin, who discovered Macy's galaxy, belong to this forward-thinking generation. They view Webb's images with an open mind and have been studying them since their release. Both cosmologists emphasize that we simply don't yet know what will happen in astronomy. We need to wait for more data. Webb's latest pictures could change everything. Was Hubble at fault? One of the great debates in modern cosmology revolves around the Hubble constant, the rate at which the universe is supposedly expanding. In the 1920s, Edwin Hubble discovered that distant galaxies were moving away from us, which led him to infer that the universe is expanding. This idea was later developed further, and Belgian cosmologist Georges Lemaitre proposed that this expansion began from a single point, the Big Bang. However, today we know from alternative methods that the expansion of galaxies can be explained differently, yielding a completely different picture. Yet, these methods have been largely ignored because older theories were deemed more likely. The more we observe the universe, the more inconsistencies arise. This issue didn't start with Webb. Decades ago, there were already areas in space where expansion behaved differently, sometimes faster, sometimes slower or denser or more sparse. This led to theories that perhaps there were multiple starting points, or even that our universe is influenced by sources that don't all have to have begun simultaneously. Webb has only deepened these debates. But what has truly happened? We seem to be at a critical juncture where either our current physics doesn't apply universally, or we've only scratched the surface of what exists. Ancient knowledge, such. Scientists have long relied on old speculations about the universe, particularly those centered on the notion of a huge explosion. However, recent advancements have momentarily revealed what is now being called the Hubble tension. This strain shows clear inconsistencies in distance measurements across the universe, depending on the reference points used as measurement constants. Currently, scientists believe that the James Webb Space Telescope, as it continues its mission, will be able to resolve this tension by making precise measurements of cosmic distances and redshifts. This could correct past errors in measurement techniques and lead to new insights into advanced physics. Throughout history, scientists have worked tirelessly to find explanations and formulating theories, ultimately expanding humanity's understanding of the universe. Instead of focusing on past mistakes, we should look forward and celebrate each new discovery, whether it seems novel or initially shocking. New theories and alternative explanations are emerging, and we may be at the beginning of a new scientific era. The investigation into these ancient points of light could reveal whether they are disks or planes of vast black holes. This could lead us to reconsider our cosmology and determine if black holes played a much more significant role in shaping the universe than previously thought. One hypothesis pointing to this comes from British scientist Roger Penrose, who proposes that the universe continually reproduces itself in cycles, with black holes possibly storing vast amounts of information. Penrose put forth this theory long before the Webb telescope was launched, and though he is a respected researcher, his work wasn't widely accepted until now. The Webb mission has only just begun, and we've already seen a second deep image and the discovery of an ancient structure so massive that it doesn't fit into the traditional view of a young universe. The evidence is growing, and we must wait to see what new images from Webb will reveal. The telescope isn't only investigating the young universe, it is also working against the clock to deepen our understanding of exoplanets, discover new worlds, shed light on our own solar system, and capture the most incredible and detailed structures in the universe. Every observation contributes to the puzzle that completes our understanding. Even measurements of exoplanets can broaden our view of the larger picture and offer valuable clues about unknown forces, phenomena, or previously hidden details. There must be some underlying grid, and scientists are searching for its dimensions, patterns, and connections. As stated by Adam, a former NASA chief researcher, at the launch of the James Webb Space Telescope, this is a monumental chapter in our understanding of the universe. It promises to push the limits of our knowledge about planets and the origins of life itself. What began with high expectations has now become a critical debate. The unexpected discoveries from Webb have stunned the scientific community. Will this disturbance deepen, or will new findings and debates in physics finally reach a resolution? But what exactly does this mean? Have scientists truly solved the puzzles presented by Webb's discoveries, or are we being presented with incomplete explanations, initially intended to provide clarity? The $11 billion project has instead plunged cosmology into turmoil. Every aspect of space-related science is undergoing a seismic shift, similar to the worldview change from geocentrism to heliocentrism in the medieval period. We may have to acknowledge that the foundations of current physics are flawed, and our understanding of the universe is far from complete. So how did this happen? Modern astronomy, the study of the properties and interactions within the universe, stems from principles dating back to ancient times. The early observations led to the initial ideas about mechanics and elements, with Sir Isaac Newton later defining gravity, which is essential to astronomy. These principles supported our understanding of the universe, where we extrapolated Earth's observable masses and forces into the cosmos, yielding consistent results. However, as our observable universe expanded, these known factors no longer fit the observations. This crisis began with conflicting results from different methods of measuring the universe's age and expansion rate. Local measurements based on cosmic objects clashed with those of the early universe determined from the cosmic microwave background radiation. This discrepancy is known as the Hubble tension. The Hubble constant, which indicates the universe's expansion rate, was called into question in the summer of 2022 when Webb discovered various ancient, highly evolved galaxies. These findings cast doubt on the universe's age. If it's truly 13.8 billion years old, it couldn't have formed galaxies only 200 to 300 million years after the Big Bang. Our physics suggests galaxies take billions of years to form. Webb's discovery suggests some galaxies existing before the Big Bang, challenging the traditional cosmology that places a 138-billion-year-old universe expanding from a single starting point. We face a critical moment. Either we are misunderstanding natural physics, or we've only just begun to uncover the true nature of the physics at play. The ancient saying, "as above, so below," suggests that cosmic physics should reflect natural physics. Maybe we've overlooked forces and dimensions on Earth that are now visible in the universe. Webb's unprecedented capabilities are astonishing. Its 18 hexagonal mirrors capture very faint light signals, detecting light that has traveled across space for more than 13 billion years. Innovative observation techniques make these faint traces visible for the first time. This cutting-edge technology has revealed light from the universe's earliest days, formed shortly after the Big Bang. In mid-2022, these distant galaxies already appeared fully developed, billions of years older than expected. This anomaly has led some researchers to consider these observations impossible or implausible. However, Webb's data is clear. Science must now confront the possibility that it has been on the wrong path for over a century. The rough age of our current cosmological model is being called into question. The truth revealed by Webb is undeniable. Yet, despite Webb's impeccable performance, many in the scientific community struggle to reconcile these new insights. Resistance from traditionalists against abandoning the Big Bang or the concept of continuous expansion reflects historical resistance to paradigm shifts, just as it took centuries for the Church to accept heliocentrism, despite overwhelming evidence. Today, scientists face a similar reluctance, even though modern researchers are no longer hindered by the oppression Galileo faced. Yet, scholarly opposition to groundbreaking discoveries persists. Imagine devoting your life to a theory, only to find proof that challenges your beliefs. These discoveries are difficult for anyone to accept. Thanks to Webb, a revolution has now begun, a revolution still causing confusion and heated debates. But we can hope that this crisis will bring us one step closer to understanding reality.